Dear students and my teacher friends, Namaskar. I welcome you to the presentation lecture on function of liver and gallbladder. First of all, the name of your exam in the green color, the name of your exam, medical entrance examination. Now, who framed the syllabus of this exam? Which is the institute? Medical Council of India has prepared this syllabus. In which year? From which year this syllabus is implemented? Year 2013. Now, where this topic function of liver and gallbladder belong to your syllabus? Human physiology, chapter name, digestion and absorption, digestive gland. Over here, this topic belongs. You are having copy of syllabus. I am also having copy of the syllabus. Now, where are we today? What we are doing? We are over here. I am delivering the theory lecture. You are attending the theory lecture. After that, you are a student. What do you need to do? Student prepares the theory lecture. You are reading. You are understanding the topic. After that, you are practicing the MCQs. And I am helping you, I am guiding you for your MCQ preparation. After that, revision of the topics. Who is going to revise? You are going to revise. How many times? Again and again. Until your exam. Now, for point number 1 to 4, I have used the red color. And for point number 5, I have used the green color. And you can understand why I have used the red color over here and why I have used the green color. Now, as far as today's topic is concerned, this is the theory notes of today's topic. I am showing the entire lecture. Okay. So this is the entire lecture. Now you want to do it, you want to prepare it by your own, you want to mug up the things, then I have given you the notes. Lecture is over. Tata, bye bye. Now you want to understand the topic, then wait. I am delivering the lecture. Now you see the topic is very flat. It is a dead topic, rather we can say. And when we try to mug up the things, it becomes very difficult. And at the same time, it is very painful. And this way we cannot prepare the topic. Now before I start this presentation lecture, I would like to show you some important figures this is the liver. This figure, in this figure, anatomy and the histology is covered. You go through all the names. Then this figure, role of hormones, cholecystokinin, secretin. So in our previous lecture we had discussed this thing, but this is also very good concept map. So you can go through this. 1, 2, 3, 4 points on the left are written. Title of the figure, control of bile secretion and release. Then this figure, what is this? What this figure is for? So this figure is showing the circulation, blood circulation to the liver and the direction of the bile flow. So I am trying to zoom out. So this is the half part. Okay. Then this is hepatic portal system. So this topic, this figure, we can discuss in the digestive system, this figure, and mainly this topic, hepatic portal system, it is discussed in the circulatory system. Then this figure, this figure. And this figure. All the names. Cholecystokinin and secretin, from where they are secreting and where they are acting. What is their role? Okay, now I am starting this presentation lecture. So here you see, in this is the first paragraph, okay, and you see the points, how I am making the points. This is the first point. So the title, function of liver and gallbladder. This is the title of today's presentation lecture. Now we know the liver, 80% of the liver area is covered by hepatocyte, and these hepatocytes are the cells of the liver. And daily this hepatocyte secreting 800 to 1000 ml of bile, that is approximately 1 liter of bile, is secreted by the hepatocyte on the daily basis. Color of the bile, yellow, brownish or olive green liquid. The bile is pH 7.6 to 8.6. Composition of bile, mostly water. Then the bile salts are present, cholesterol is present, phospholipid called lecithin is present, bile pigments are present, several ions are present. Now for this first point, I am showing you one table. So the table shows the composition of liver bile and gallbladder bile. So we can compare liver bile, gallbladder bile. The component of both the bile. So in the bile, what is present? Water, bile salt, bilirubin, cholesterol, fatty acid, lecithin, and the iron. Which are the ions? Na plus, K plus, Ca twice plus, Cl minus, SCO3 minus ions are present. And this is the amount in which they are present. But this number, we don't have to remember this number, so you don't require to prepare this number. Okay, just it is simply we are comparing. See, the water 97.5 gram per deciliter, and in gallbladder 92 gram per deciliter. Now you see, in the liver bile more water is present, in the gallbladder. In the previous lecture we have learned that how this gallbladder is absorbing the water, and the gallbladder is concentrating the bile. So since the bile is concentrated in the gallbladder, it is having less amount of water. So this was the first point. Now here, same thing, liver bile, gallbladder bile, water 97%, 85%, but you don't have to prepare this number. This is just for our information only. These are the structure of the bile acid, cholic acid. Then this one is also, this is cholic acid, this one is colonic acid. Just go through once the structures. Now what are the biles? So the different biles are hydroxy derivatives of colonic acid, and their names are given. So these are all derivative of colonic acid, bile acids. Now the second point, now second point, you can go through this second point. Oh, 1 minute.
क्या मैं आपके साथ अभी एक्सरसाइज कर सकता हूँ?
I am sorry for this interruption that caused to you. Now this is the second point. The principal bile pigment is bilirubin. Now the entire theory point is written over here, this theory point. You can go through this theory point, and I'm directly explaining this. See, this is the bone marrow. So the bone marrow is present in the longer bone, red color tissue, and the bone marrow produces the RBC. So that process is known as the erythropoiesis, formation of RBC. Where these RBCs are going? They are entering into the bloodstream in the main circulation. So in our blood, RBCs are present. What is the role, what is the function of this RBC are having? So they are transporting O2 and CO2 in our body. They are involved in the transport of O2 and CO2. And when they become old, we know the age of RBC is 120 day, and after 120 days, where these RBCs are going. So see, these three organ: spleen, liver, red bone marrow. In these three organ, macrophage are present, and this macrophages, they are performing the phagocytosis of old RBC. So in the macrophage, what is happening here? The RBCs are shown, and these RBCs are broken down. So from RBC, the globin is released, heme group is released. Now from the globin is further broken down, and the amino acids are released, and these amino acids are reused for the protein synthesis. So from the amino acid, proteins are formed. Now what is happening to this heme group? So from the heme group, Fe3 plus is released, and from the heme group, biliverdin is released. Now, as you can see, from this Fe3 plus entering into liver, then from the liver again it is reaching to bone marrow, and this Fe3 plus is reused in the formation of the RBC. Now what is happening to biliverdin? So formation of bilirubin from biliverdin is the catabolic process, and this is the first catabolic process in the macrophage, and the enzyme responsible for this catabolic process is biliverdin reductase. So with the help of this enzyme, biliverdin is converted into bilirubin. Where this bilirubin is going? Bilirubin enters into liver. From the liver, bile is secreted. So bile is poured into small intestine. Now in the small intestine, what is happening? So on the bilirubin, bacteria is acting. Biliverdin is converted bilirubin is present in the small intestine. Now in the intestine, bilirubin is acted upon by the bacteria, and bilirubin is converted into urobilinogen. Urobilinogen enters into the kidney, and it is converted into urobilin, and this urobilin is excreted in the urine outside our body. Some of the urobilinogen is converted into stercobilin. Okay, and where this stercobilin is present? So it is present in the large intestine, and in the large intestine, what this stercobilin is doing? So stercobilin is giving ficus the normal brown color. So the brown color of the ficus, for that brown color, the stercobilin is responsible, and we have learned now that how this stercobilin is produced from the bilirubin. So this was the second point of our today's discussion. Now this is very important figure for you, so I am showing you the entire figure. Now moving on the third point of our discussion. Now the third point is regarding the bile. What is bile? So bile is partially an excretory product and partially bile is acting as the digestive secretion. Now in the bile salts are present, and what these bile salts are made up of. So actually in the bile salt, in the formation of bile salt, there presents the bile acids and they combine with sodium or potassium. So the salt of sodium and potassium of the bile acids are known as the bile salt. So what are bile salt? Sodium salt or the potassium salt of the bile acids. Which acids? Deoxycholic acid and the cholic acid. These are the bile acid. What is the role of this bile salt? What is the function of the bile salt? So bile salt play a role in emulsification, and emulsification is the first process in in lipid or the fat digestion. So the first step of the fat digestion, lipid digestion, is the emulsification, and the bile salt are involved in the emulsification process. Now here in this figure, in the liver, cholesterol is present. This is the cholesterol. From the cholesterol, primary bile acids are formed. You can read the names: deoxycholic acid and the cholic acid. Now this primary bile acid, where they are going, they are stored, this bile, they are stored in the gallbladder. So in the form of, and they will form this salt with sodium and potassium. So the bile salt or the bile is stored in the gallbladder. Now we know from the gallbladder, bile will be poured into the intestine, duodenum. So in small intestine, what is happening? This primary bile acid, they are biotransformed by intestinal bacteria, and then there is a formation of secondary bile acids. The secondary bile acids are deoxycholic acid and the litocholic acid. Now here, structure of the taurocholic acid. These are all various bile acid. Glycocholic acid. Then this is the bile salt is shown. We are discussing this structure of bile salt after few theory points. Now moving on the fourth point. So I have shown you this. See, bile salt, cholic acid plus glycine, glycocholic acid, cholic acid plus taurine, taurocholic acid. Now, sodium or potassium glycocholate and sodium or potassium taurocholate are the two bile salt. And in human bile, sodium or potassium glycocholate predominates. It is the main one. And this sodium potassium glycocholate is 3 times as much as sodium or potassium taurocholate. Okay. Now, this is the structure of cholic acid. And you see, cholic acid combines with glycine or it combines with taurine. So what happens? So when cholic acid combines with glycine, then that time glycocholic acid is formed, or when it combines with taurine, then taurocholic acid is formed. Now, this is the structure of quinodeoxycholic acid. Quinodeoxycholic acid combined with glycine is added to quinodeoxycholic acid. Then glycoquinodeoxycholic acid is formed, and quinodeoxycholic acid combines with taurine. Then tauroquinodeoxycholic acid is formed. Now moving on the fourth point. Now in the fourth point, bile salt. Now what is the role this bile salt are playing? So they are participating in the lipid digestion, the first process of lipid digestion, emulsification. What is happening in emulsification? So large lipid globules, they are broken down into a suspension of small lipid globule. So here in the figure, you see this is the fat globule is shown, and here this green in color bile salt is shown, and the phospholipid is also shown. So bile salt along with the phospholipid, these two together, they are acting on fat globule, and they are converting this large fat globule into the smaller droplet, and these droplets are known as the emulsion droplet, and this process is known as the emulsification. So you can read this right hand side figure, that is the emulsification of fat. So emulsification of fat by bile salt and phospholipid. Now what they are saying, not that non-polar side. See, first of all, here you see, for this we need to understand the structure of bile salt. So we need to understand this figure, structure of bile salt. Now in figure A, chemical formula of glycocholic acid is shown. Okay, and what is glycocholic acid? So glycocholic acid is one of the bile salt. Okay, and liver secretes many bile salt, and among them one is glycocholic acid. So you see the structure of, this is the structure of glycolic acid, and glycolic acid is one of the bile salt. Now the same bile salt, glycolic acid, is shown over here. But what is this figure B? So the figure B is the three-dimensional structure of a bile, showing its polar and non-polar surface. So this surface is the polar surface of the bile salt, and this one is the non-polar surface. Here the carboxyl group is present, then red color hydroxyl group are present. So let's find out this carboxyl and hydroxyl group. Okay, carboxyl hydroxyl group. Okay, so hydroxyl group they are showing in red in color. Okay, now here what they are writing: non-polar side green of bile salt, non-polar side green of bile salt, and phospholipid, this one oriented toward fat. They are present, they are attached to the fat, whereas the polar side, which is red in color, this compound, they are oriented outward. So this red color part, which is the polar side, it is away from the fat. That is the meaning of this figure. So this is the role of the bile salt, how the bile salt is involved in the emulsification process, and this is the very nice figure, and with the help of this figure you can understand the role of bile in the emulsification process. Now moving on the fifth point. Now in the fifth point, what they are describing, now we are having, after the emulsification, there are small lipid globules in the intestine, and this small lipid globule, they provide very large surface area for the action of pancreatic lipase enzyme. So as the surface of lipid has increased now, this enzyme lipase can act very rapidly on the small lipid globules. So this lipase is acting on the triglyceride, and we know in the structure of lipid the triglycerides are present. Then once these triglycerides are digested, these bile salts are also helpful in the process of their absorption following their digestion. So once the digestion of lipid is completed, these bile salts are also helpful in the absorption process. They are also playing a very vital role, important role in the absorption of fat. So how they are playing a role? So see, over here the fat droplet is shown. We have just learned how the bile salt and phospholipid, they are involved in the emulsification. So now we are having the smaller lipid globule, and this smaller one are the emulsion droplets. And on this emulsion droplets, they are further acted by bile salt and pancreatic lipase in the lumen of small intestine. And now we are having the very small measles. Okay, so here these are the measles. Okay, so how these measles are formed? How these measles are formed? So here you see this one is the emulsion droplet. This is lipid, and the lipid in the lipid structure triglyceride is present. Now what is the structure of triglyceride? In the structure of triglyceride, glycerol is there. Glycerol combined with 3 fatty acid. That is the structure of triglyceride. Now who is acting on this emulsion droplet? Bile salt and lipase, they are acting on emulsion droplet. Then what happens? Now this triglyceride, they are digested, they are broken down into monoglyceride. Now what is monoglyceride? Glycerol plus 1 fatty acid. Glycerol and 1 fatty acid are present in the structure of monoglyceride, and the rest of the 2 fatty acid, they are released. So now what is happening? This monoglyceride and fatty acid, you see, they are take part in the measle formation. And how the measle are formed? So this monoglyceride and fatty acid, they are surrounded by bile salt. So in the measle, what is there? In the measle, monoglycerides are there, and the liberated fatty acids are there, and they are surrounded by the bile salt. This structure is known as the measle. Now what happens? In the process of fat digestion, these measles are broken down. So here you see the measles. Okay, measles are broken down. So when the measles are broken down, what happens? The monoglyceride and the fatty acids are released, and the diffusion of monoglyceride and fatty acids occurring. They are diffusing, and they are entering into the cell. Which cell they are entering? So they are entering into the epithelial cell of the small intestine. And all this thing I will discuss with you in the lecture of lipid absorption, because this lecture is about the function of the liver on gallbladder. That's why. So up to here, now we understand that the bile salt, they are participating in lipid digestion first process, that is emulsification, how they participate, and how these measles and how the measles are broken down, and how they are entering, how they are absorbed by the epithelial cell. So I would like to show you the entire figure. This figure is also very useful to you, so you go through entire figure. Now moving on the sixth point. Now sixth point. See, hepatocyte, although they are continuously releasing the bile, they are secreting, they are producing the bile all the time, the hepatocyte of the liver. But they increase this bile production and the secretion when the portal blood contains more bile acid. That means when the digestion and absorption is happening, is continuing in small intestine, that time bile release from the liver is increased. That means after our meal that we have taken, so the meal, the food that we chew, and the bolus, and then the bolus, then it enters into stomach, then the chyme enters into the duodenum, then the jejunum, and the ileum. So the main digestion process, it begins in the duodenum. Okay. So when the digestion is occurring, it is taking place in the parts of the small intestine. That time, more bile is secreted by the liver. That is the meaning of this thing. Now between the meals means let's assume that one meal we have taken in the morning and one meal we have taken in the evening. So that time period we can say that is the between meal time period. And in this period what is happening? Most of the nutrients are absorbed. Okay, and in this time bile flows into the gallbladder, because now there is no role the bile has to play into digestion process, because digestion process is already completed. So now the bile enters into the gallbladder for the storage, and here it is not only stored but it is concentrated as well in the gallbladder. And in the previous lecture we have understood that how this bile is concentrated, how the water is removed from the bile. That thing we are knowing. So now the sphincter, see, so during our meal, when the digestion is over and most of the absorption is over, during that time, let's say in the afternoon or early in the evening, early evening, there is no requirement of bile. So we know this one is the green color common bile duct. This is the main pancreatic duct, and this is the ampulla, and ampulla opens into the duodenum, and this ampulla is surrounded by a wall, and this wall are known as the sphincter of Oddi. So the smooth muscle of this wall, they remain contracted, so they are closing this ampulla, so bile cannot enter into the duodenum. So that is the meaning of this entire sixth point. Now moving on the seventh point of our discussion. Now additionally, see, main function of the liver is to secrete bile, but there are some more function that the liver is involved in. So see, in addition to secreting bile, and this bile is needed for absorption of dietary fats, the liver performs many other important functions. For example, carbohydrate metabolism, In that, the liver is involved. Liver, especially important in maintaining normal blood glucose level. Now what happens? Let's say the person is starving. Let's say the person is starving, suffering from starvation, or the person has kept a fast. So during that time period, what will happen? In the blood, the glucose level will be low. So at that time, to increase the glucose level in the blood, liver breaks down the stored glycogen, and the liver converts glycogen into glucose, and this glucose is released into the main blood stream. So here you see this is the liver glycogen, and it is broken down into the glucose, and this glucose is entering into the bloodstream. Then liver can also convert amino acid and lactic acid into glucose whenever it is required. Then liver can also convert sugar such as fructose and galactose into glucose. So before moving on the 8th point, I discuss 8th point with you, you go through this figure. Now here, these two figures are also very important. Three important concepts in these figures. First concept is the process of glycogenesis, and the second process, glycogenolysis. Now what is happening in glycogenesis? So the glycogenesis pathway converts glucose into glycogen. So let's see this process, glycogenesis, conversion of glucose into glycogen. See, this is blood glucose. From the blood, glucose is entering into liver. Inside the liver, what is happening? Enzyme hexokinase. Then ATP is converted into ADP. Release phosphate combined with glucose. Glucose 6-phosphate is formed. Glucose 6-phosphate converted into glucose 1-phosphate. Glucose 1-phosphate converted into uridine diphosphate glucose. And this is converted into glycogen. So this conversion of glucose into glycogen is known as glycogenesis. Then the second process, glycogenolysis. In glycogenolysis, what is happening? Glycogen is converted into glucose 1-phosphate by the enzyme phosphorylase. Glucose 1-phosphate converted into glucose 6-phosphate. Glucose 6-phosphate is converted into glucose by phosphatase. So this conversion of glycogen back into glucose, that process is known as the glycogenolysis. Now the hormones are involved in both the mechanism. In the red arrow, glycogenesis, this process is stimulated by insulin, and glycogenolysis is stimulated by glucagon and epinephrine. Then this process, gluconeogenesis. What is gluconeogenesis? conversion of non-carbohydrate molecule, amino acid, lactic acid and glycerol. They are converted into glucose. So see over here, lactic acid, glycerol and amino acids are shown, and in the liver cell they are converted into glucose. Now the key point, about 60% of amino acid in the body can be used for gluconeogenesis. So in our diet protein is present, we digest protein, we get the amino acid. Then we can convert back mainly the amino acid. We are building our own body protein from the amino acid. There is the process of absorption of amino acid, assimilation, all this process are there, and mainly we are using amino acid for the buildup of our body's enzymes and proteins. But the extra amino acid whenever it is needed, so amino acid can also be converted into glucose, and this mechanism is known as the gluconeogenesis. So here you can see the lactic acid, amino acid, glycerol, they are converted into glucose. Okay, and this process, gluconeogenesis, is stimulated by cortisol and the glucagon hormones. So now we are moving on the eighth point of our discussion. So see, when the blood glucose is very high, for example, after eating the meal, the liver converts the extra glucose into glycogen. Most of the glucose after digestion, it will enter into the main bloodstream, main blood circulation. But what happens to extra glucose? So this extra glucose via portal system, portal vein, hepatic portal vein, it reaches into the liver, and in the liver it is converted into glycogen. So glucose is stored in the form of glycogen in the liver. Then from the glucose, triglycerides are formed, and these triglycerides are also stored in the liver. So entire mechanism I am showing you. Small intestine, digestion is taking place. After the digestion of carbohydrate, protein and lipid is completed, we are having amino acid, glucose, then triglyceride. Triglyceride, when they are digested, we know they are converted into fatty acid and alcohol. Now from the bloodstream, glucose entering into liver, amino acid they are entering into liver. This glucose is converted into glyceraldehyde 3-phosphate, glucose converted into fatty acid. From the fatty acid and glyceraldehyde 3-phosphate, these two combine and triglyceride are formed. Then glucose is stored, glucose is converted into glycogen, glycogen is stored in the liver. Then amino acid entering into the liver, and they are forming protein. From the amino acid, keto acids are formed. From the keto acid, fatty acids are formed. Fatty acid take part in the formation of triglyceride. So this triglyceride is stored in the liver. Glycogen is stored in the liver. So these are also the functions of liver. So this was the 8th point. Now moving on the 9th point of our discussion. See, lipid metabolism. Liver is also involved in the lipid metabolism. So hepatocyte, the cell of the liver, they store the triglycerides. Now here you see liver stores the triglyceride. Triglycerides are formed in the liver, and where this triglyceride are going? So this triglyceride, they are transported into the adipose tissue, or in the adipose tissue the triglycerides are stored. And what happens to triglyceride? Okay, so this adipose tissue is storing the triglyceride. Okay, and the adipose tissue is present beneath the skin in our inferior abdominal region, particularly in men, and in women this adipose tissue is predominantly present in the hip region. Okay, so due to this adipose tissue in men, the tummy comes out. Okay, because the triglyceride, they are stored. So more we eat the fat, or more we eat the food, more the triglyceride is formed, and more the triglyceride is stored in the adipose tissue via liver. So this was the 9th point. Now moving on the 10th point. Now this figure, I would like to show you this figure, the entire figure, important one for you. And this figure. Then first I will show you this figure, entire figure you go through. Now we are discussing the breakdown of fatty acid. So just now we have learned that in the adipose tissue triglycerides are stored. Now what happens to triglycerides? So whenever there is requirement, this triglyceride, they are converted into glycerol and fatty acid in the adipose tissue, and they are transported, the glycerol and fatty acid, they are poured into the blood stream. From the blood, they are entering into the liver, the glycerol and fatty acid. Then in the liver, what is happening? Breakdown of fatty acid and generation of ATP is taking place in the liver. So 10th point. Now moving on the 11th point of our discussion. Now we have learned that in the liver proteins are formed. In the liver triglycerides are formed and stored. Triglyceride means lipid. This triglyceride combined with lipoprotein. So lipoproteins are formed in the liver. And what the role of these lipoproteins are playing? What's the function of these lipoproteins? So these lipoproteins, they are involved in transport of fatty acids, triglycerides and cholesterol to and from body cell. So these lipoproteins, what they are doing? They are transporting fatty acid, triglyceride and cholesterol to the body cell, and whenever there is a requirement from the body cell, they are transported back to the liver. And in this transportation, the lipoproteins are playing a vital role, and these lipoproteins are formed in the liver. So formation of lipoprotein is also the function of liver. Now moving on the 12th point. Now before I discuss the 12th point, I would like to show you one figure. This one is also both the, in fact all three process I have discussed with you: glycogenesis, glycogenolysis, gluconeogenesis. Okay, but this way, if you want, you can prepare. Now 12th point: liver synthesize cholesterol, formation of cholesterol in the liver, and cholesterol is used for formation of bile salt. So bile salt are produced from the cholesterol in the liver. Here in this figure, the bile acids are shown. Now moving on the 13th point. Now I am showing you the 13th point. This is the 13th point. You can read this point, and I am directly explaining you this point number 13. So this point is for protein metabolism. Now in the liver, what is happening? In the liver, there are two processes. One is transamination and second one is the oxidative deamination. Now in transamination, what is happening? Amino acid combined with keto acid, that is alpha ketoglutarate acid. Keto acid and amino acid, that is glutamic acid, is formed in transamination. Now this way, I know it is difficult, so with the structures we learn this process, transamination. So here you see transamination, alpha ketoglutarate combined with amino acid, glutamate and alpha keto acid is formed. This is transamination. Now oxidative deamination. From the amino acid, that is the glutamic acid, ammonia is removed and rest of the amino acid is transformed into keto acid. So now I am showing you the figure for oxidative deamination. So here this is the structure of glutamic acid. Glutamic acid combined with water molecule. This is amino group NH2. NAD, nicotinamide adenine dinucleotide, it is reduced to NADH2, and glutamic acid is converted into alpha ketogluteric acid, and there is a release of ammonia. Where this ammonia is utilized, so ammonia take part in the urea cycle. So here in the figure you see this ammonia combined with CO2 in the liver, urea is formed. From the liver, urea enters in the blood. Then blood supply to the kidney, urine formation in the kidney, and with the excretion with the excretion of urine, the urea is removed from the body. So this is the point number 13. Moving on, point number 14. Now, in point number 14, the function of liver, processing of drugs and hormone. Liver process the drugs and the hormone. Now, see, liver can detoxify substances such as alcohol. Once again, I am reading this line for you. Liver can detoxify substances such as alcohol. That means alcohol is toxic substance for our liver. And which topic we are discussing? We are discussing the functions of liver. And consuming alcohol, that means consuming toxic substance in our body. And this alcohol is harmful to our liver. So as a student, you are studying the function of liver. Now you are knowing the damage that the alcohol is causing to liver. So that means in our life we should not touch the alcohol. We should avoid drinking, okay, of beer, whiskey, wine. Okay, we should not consume alcoholic beverages. So this is the clear-cut line they are mentioning in the biology. So now the liver can detoxify substance such as alcohol, then excretion of drug, for example the tablets that we have to take whenever we fall ill. So in this tablets, penicillin is there, erythromycin, sulfonamide, okay, and these all they are excreted into the bile. Then liver can also alter means change or excrete. So liver is capable of altering the structure of the hormones. At the same time, it can also excrete the hormones. For example, the thyroid hormone, steroid hormone, that is the estrogen and the aldosterone. Moving on the 15th point of our discussion. Now we have already discussed this point. Okay, so you can go through this. This point is repeated. Now this point number 16. Synthesis of bile salt. So liver synthesizes, liver produces, liver forms bile salt. And bile salt, we now know the process of emulsification, the role of bile salt. So what the bile salt are doing, so they are involved in emulsification process of lipid, and in that process large fat droplet, they are converted into the smaller lipid lobule or the fat lobule. So bile salt, they are involved in the emulsification, that is the first process of lipid digestion. They are involved in, and the bile salt are also involved in the absorption process of the lipid. Point number 16. Then point number 17, storage function. Glycogen is stored. Then in addition to glycogen, liver is also a very prime storage site for some other substances. Certain vitamins, for example, vitamin A, B12, D, E, and K are stored in the liver. Then the minerals, iron and copper, are stored in the liver. And whenever there is a requirement, the liver can release the stored vitamin and the minerals in the bloodstream. Okay, so this is point number 17. Then phagocytic function of the liver. In the liver, stellate reticuloendothelial cell, that is the Kupffer cells, are present, and these cells, they phagocytes red blood cell which are aged. So liver cell, they are destroying, they are breaking down the old RBCs. Then liver is also phagocyte the WBC, and liver cell, they are also killing the bacteria. Then the last point number 19, activation of vitamin D. Now, 3 organ, skin, liver, and kidney, they participate in the formation and activation of vitamin D. Okay. So with this, we have completed the topic of function of liver and gallbladder. I hope you have enjoyed this presentation lecture, and at the same time I also hope that this presentation lecture will be helpful in your exam preparation and also in your studies. My name is Manish Koshti sir. I am from Ahmedabad, India. Bye bye. Namaste.